Okay, so I am back for another DevBlog. I have gone into hiding for quite a long time. It's been quite a while since I uploaded the last DevBlog, and I think it was about animations that I implemented in some of my models. And yeah, it so turned out that there were fundamental problems with the engine I was using. Yeah, so just you may have seen the one of my other videos where I sort of showed the relay and the entrance to a more or less futuristic city, which is probably gonna change still. And it kind of, it was this, as you can see here. This was the sort of intro video I recorded, and you can see it's moving slightly, and you will notice that the turrets are moving, yeah. But the one fundamental problem with all of this is that there are no shadows, yeah. So I mean, it looks really cool as such, yeah. I mean, it looks sort of alive, and uh, there are a few things going on. I mean, I did change the textures here. I think I recorded another video, but this is probably older with the repetitive textures here. Yeah, it looks kind of boring. I changed those a long time ago. The point is that the models don't cast shadows, and the light source is coming from behind. Yeah, so like sort of from somewhere, like as if you were leaving the screen, like sort of coming toward yourself. That's where the light is. And yeah, but I sat down with the engine. It is called Mini B3D, and it's sort of like an OpenGL wrapper for BlitzMax, which is the language I'm using to program this in. Yeah, and I had a long and good look into Mini B3D, and I couldn't find anything that would help me in sort of uh, casting shadows, and so I thought maybe I should abandon this pre-baked engine altogether and start from scratch, and that's what I did. Yeah, so I created my own engine. Yeah, and it was called Reticulum Engine before, but I received some very interesting feedback. One of my friends said it would kind of sound like it is as if this was like it comes out of a Harry Potter movie, yeah, and we don't really want that. And so I renamed I renamed the whole thing into something more simple and something easier to remember. It's now called a Reason Engine, yeah, and I would very much like to show this to you. It's uh, not, so that you don't get the wrong idea. Like, this is very at the moment a very basic framework. Yeah, but I want you to I want to run through the steps, or some of the steps that you would have to do with the engine in order to create a program. Yeah, um, and yeah, so let's begin. Um, I actually, just in case you wonder, I purchased Blide, yeah, the IDE about Blide, which is probably one of the, or the most advanced BlitzMax IDE that's currently out there. And if you're really doing some serious stuff, some large-scale projects with BlitzMax, you have no way there's no other way to purchase this, because that's a real professional IDE, and you should actually get this. Yeah, you can get this under blide.org. There's also free edition if you don't necessarily want to spend money right away. You can test the program and see if that's really something for you. Okay, so if you want to use my engine, yeah, the first line you would obviously have to do is import, yeah. And what I find really cool is that it sort of gives you suggestions as to what you want to do next. Yeah, so see a reason. I will be cheating a little bit because because this program can do it for me. So reason engine, that's the first thing you want to do, and for some reason it capitalizes the engine. I don't know why. I don't really want to do this, but yeah. Anyways, so the first line, import reason.engine, defines that you want to use that particular framework in your program, yeah. And now what you want to do obviously is create a window, yeah. So to that end, there's one line you have to write, one line, yeah. In C++, that's approximately 2,619 lines. We do it with one, yeah. So it's called rn for reason, and then create app, yeah. Rn create app, and you will have to define whatever is appearing in the title bar, yeah. So we're gonna say reason demo, oops, demo, demo. The next thing you want to do is define the window width, and we're gonna say 1440, and the window height, yeah, which is 900. That will create everything for you. You don't have to worry about anything else. And now what you want to do is create a program loop, yeah. And I like to do it with a repeat until, yeah. So repeat flip for the moment, and then until app terminate, yeah. So that would already be running. So if I compile this right now, you see it comes up with a window that's absolutely black. But so that's it. You have your OpenGL based application here. Inside you can begin with commands of the engine. There are about 60 or 70 right now. Yeah, so there's also a camera that you can move, and one thing you probably may want to do just to see the capabilities, or like how easy it is to do something. So let's just say that we want to create a simple cube, yeah. So that would be rn create cube, yeah. There really isn't anything else, or there is, yeah, the name. Now, it is important to understand that everything in my engine is based on names. So everything in the engine has a unique name that will help you to refer to a certain object, yeah. So in this case, rn create cube, and we call it a demo cube, yeah. And that's really it. There's not much else you have to do. And the camera the first camera is called default. I support up to 16 cameras, yeah. So let's say rn position camera, and you will have to define the name, and that will be default, yeah. And we want it at the 0 position. Like, you will have to define a vector at where you want to position your camera. So 0, 0. And we're gonna say -50, which is sort of towards you, like as if you were sort of leaving the screen. -50, right? And we also want to do something with the cube, because right now it's just one unit, one OpenGL unit, and that's relatively small. So rn scale model demo cube, okay. And the scale, yeah, so we want it up to 10. Now there are two scale functions, yeah. There's one called rn scale model, yeah, which is a uniform scale. So you provide one value, and it will scale from the current scale to whatever you define, yeah. So if it is like 1 unit, it will expand 10 times, yeah. So but if you use the same command again, like the cube is already 10 in size, yeah. So if you say scale model 10 again, it will blow up to 100 units, because that's a relative scaling, yeah. So that's that. And in order to see what we did, yeah, there's one call you have to do in your main loop, and that's called rn render, yeah. That's it. There's that is it, okay. We are looking at 13 lines, and that will hopefully give us a cube. There it is. See, it's a nice little cube that we're looking at, as you can see for yourself. It's the default color for objects that don't have anything is gray, is 128 gray. Yeah, and now obviously that's not everything. Yeah, so if you want to sort of do something with that cube, you could sort of provide a number, say global or global variable, Jesus, rotation, which is a float, and we also want to yeah, hang on, global rod value is float, and we want to spin it by 0.25. Yeah, so you could now go and say Rn rotate model. Yeah, and you will also have to provide the name, which is in this case called democube. Democube, and we want to spin it horizontally, so 0, and this would be rod value. Yeah, and 0. Yeah, and we want to make sure that the value increases. Yeah, so we can actually just remove this. We want to make sure that this increases, so rod value is rod value plus 0.25, and we also want to make sure that it doesn't exceed 360. Yeah, so if rod value bigger than 360, rod value is 0. Yeah, so now it should be relatively easy to understand what's going to happen now, and that's that the cube will spin, and there it is. See, it's spinning at the desired rate that you can increase if you want to, say 0.5. It will obviously spin faster. Yeah, see. You can also go and like rotate it on another axis if you want to. So rod value 0, and now you oops, yeah. So yeah. So you can see that it's now spinning on two of the three axes. We obviously you could also go and say rod value on all three axes, and that will obviously do that. If you're into science or mathematics, yeah. So I mean, that's relatively obvious. Another thing you can do is to sort of, yeah, that's, you know, Rn. Well, let's just remove this. You could also just to show the difference to you. Rn scale model 3v is a vector comprised of 3. So it would also be democube, and that would be, say, if you don't want to change the scale that it's currently at, yeah, you just do 1. Yeah, but obviously we want to have 10. If you want to sort of create a like a flat plane, you could go like 0.01 and 10.0. Yeah, that will scale it on the 2 horizontal planes, but make it small on the vertical plane. And now it's very thin. Very you can't even see it from here. So let's just say 0.5 maybe. So see, it's very thin now, and we could. Yeah, I should not have deleted that, but let's just say Rn rotate model democube, just so that you get the feel for how it's like to code in this, and it would be 0. No, actually rod value, we want to spin it on both rod value and 0, and rod value is rod value 0.5 say, and now you can see that it's like a flat, sort of relatively flat plane, and it will spin like this. Yeah. Um, so I mean, that's relatively easy to do. Um, we're just gonna leave the rotation value in here for the moment. Um, uh, Adding textures and some such is relatively easy as well. We can sort of let's just create a let's just leave it at the uniform scale, so we have cube, and the command uh, for textures is very simple. But before I do this, I want to explain to you that the engine has a built-in texture catalog. Yeah, and we can handle unlimited textures here. Okay, so like as long as you have memory, we can handle it. Yeah, and we want to create we want to add a texture here, and the command for this is rn add texture, and we want to define the file with the texture. So that's textures. I think it is possible that occasionally I will have to check the folder at where the demo is. So textures, yeah, so there they are. Textures, and let's say ccube.jpg, and we also want to give it a name, and we're gonna call it cubetext, just like that. Boom. That's it. That's your texture edit. That's it. For the technical people out there, these textures are automatically mapped. Yeah. So you just have to put this one line, and that's it. Yeah. That's it. Like you don't have to care about anything else. Now, obviously, if you want to use that texture, we can do that too. Obviously, yeah. And the command for that is one line. Yeah. So you do rn set model texture. Yeah. And this would be for the demo cube. I find this very cool because that really makes it simple. And the texture name is cubetext. Yeah, you don't have to, define anything else. Just, you just have to remember the name you gave that texture. Yeah, but make sure it's a unique name. Okay. If the name is not unique, it will omit. It just won't load. Yeah. So make sure that the name you're choosing is unique. Yeah. So that's pretty much it. Set model texture, and that will actually set the texture for the model. That's it. Yeah, and if you do this, you will see a little companion cube rotating on the screen. Yeah. Or yeah. So I think that's Fraps that's sometimes blocking us from doing shit. But yeah, so that's a little companion cube. Obviously, you're not, I could also say, I think there was one from the Nihi tutorials, Ni and Helium create.bitmap. So I could also say, I could change that here to just, create.bmp. I hope that works. So see, there you go. So that's relatively simple from that perspective. Yeah. The next thing is about camera movement. I want to keep this devblog as concise as possible, but still showing you a lot of features that are in the engine right now. Yeah, so you could also obviously move the camera. Sometimes it happens that I will copy and paste code from other things, from an example I did. For example, real quick. So yeah. So like I said, there are up to 16 cameras supported. Yeah. Now I did think about the problem of camera movement, yeah, and I built in a command for this, because we don't really have to do like remember camera coordinates and then add a number or bum. Yeah, like no, that's like no, we don't want that. Yeah, we want to live a good life. We want to be free and easy. We want to have it quick. We don't want to have it working. And for that reason, there's commands called rn enable WASD movement. That's it. That's fucking it. Like, uh, and the command for that would be true. Yeah. So if you want, that's it. F5. Let's run the shit. And I can now, uh, well, yeah, yeah. 1 second. Yeah. So when you work on an engine like this, you sometimes really forget some parts. Yeah. Uh, enable WASD movement is the line, but you also have to define how fast you want to move. You want the camera to move. Yeah. So RN set camera movement speed 2, and then the number say 2.0. That's a relatively good speed, and that's that. So hopefully if you run it now, you will see I can now move the camera in any way I like. I can rotate. I should maybe actually stop the rotation like this, so you can see that I'm actually in fact moving. See, I can now use the keys and go up close or move far away. The frustum is set to 1000 in the moment. Yeah, so everything that's like outside of 1000 will just disappear. And I don't know if you can see it, but it sort of switches the texture maps. Um, F and R is up, F is down. Yeah. So yeah. So I see moving forward like this. So that's working, as you can see. If you want to go slower, you can obviously reduce this value to 1 or whatever you like. So now I'm moving a bit slower, as you can see. Uh, that's really up to you in what way you do that. I also have to say that the engine currently supports OBJ Wavefront OBJ format. Yeah, so we can load these kind of models, and we have support for unlimited models. Yeah, so you can load and keep as many models as you like. It's really up to you. Okay, so so that's that, and basically I can show that to you. But first I will have to copy something over real quick from another folder here, which I had here, and we're gonna show you something. That this is an OBJ model. It's called a truck, and we're gonna quickly copy that into the demo folder so you can see it. Models we're gonna put. Oh, the truck is already there. God damn it! And we're gonna use the truck texture for this, obviously. Textures, truck. So that you can see that's actually working. Yeah. So but now instead of the cube, we say I didn't scale the model before, so we just say rn load model. Okay, and the name, we want to give it a name. Sorry, it's called truck, and the file is models truck.obj. Okay, because that's where it is. We want to add a texture, and that's obviously truck.jpg, and we're gonna rename this stuff here to truck text. Set model texture truck to hello. Oh, I have to get used to this new sort of keyboard, which I purchased about a week ago. Truck text, and that's pretty much it. We can now load the model of the truck, It's a very simple truck. It's like low polygon, but you will get the idea. So we can do this, and that's our truck. So we're already kind of, you know, beneath it. That's our little truck here. See, um, so you can see the texture mapping is already done for you. Um, and you know, just to show you that this is real texture mapping going on. So this is the truck, and this is the texture. Yeah. Um, and obviously, if you're doing 3D design, you know that you can map certain parts of the models to certain parts of the texture. Yeah. And this information is saved, and obviously you can import that um, in that sort of fashion. Yeah. Um, yeah. So that's working. We can spin around the truck here in any way we like. Uh, Now this is done without lighting, obviously, and we can also go like this is relatively interesting for development, I'd say. We can say we're defining a variable here. Global show wireframe is just an integer. Um, if key down key say B rn let's see if I'm not actually sure if yeah I have one. It's called rn. I hope, is it? No. uh yeah, but I can, yeah, sorry about this, but there is a mode that enables us to show the wireframe. I have to do this in the next devblog. I may have turned that off. I know there is a global variable here, which hang on, yeah, RT wireframe. So yeah, we can, yeah, okay, hang on. If key down, I'm going to experiment because I want to, real quick. Key down, key B. The internal variables are still called RT for reticulum, RT wireframe, and let's say global show wireframe is true. No, actually just key down, and if show show Jesus wireframe is false, show wireframe is true, and then yeah, not ru, it's true. RT wireframe is true. Yeah. Else if show, no, we have to do it this way because no, it was else if, yeah, I get confused sometimes. Else if show wireframe is true, then show wireframe is false, and RT wireframe is also false, and that's end if, and that's flush keys. I hope this works because I didn't you know, test this. So we have the truck here, B. See, there's our wireframe, and we can now look at the model in like in its colors, and you know how, and B. So there we go. That's the wireframe mode. I can imagine that for some of you this is useful in development sometimes. Yeah, so that's that, and as you can see, it's working properly. Now the next thing, what else am I gonna show you? There is so much in the engine right now that it's really difficult to keep track of it, and I like I said, sometimes I will switch back and forth. Like one cool command is rn set clear color, and I'm going to copy that real quick. And what it basically does is that it lets you set a different color for the background, and I particularly like this color here, 100, 100, 255, and you will now see that the background color is a nice blue, which I think is a lot more nicer for development. Um, uh, yeah, so that's that. But now one thing that's really important and that's really strong about this particular engine is that we we have a lighting system going on, yeah, and this lighting system is able to cast shadows uh, automatically. Uh, you don't have to worry about so much. Right now it works with one light, and I will have to sort of um, make it work with a lot of more lights. Um, and this is really the interesting bit. I'm gonna leave the wireframe mode in here because that's kind of cool. We're gonna turn off the rotation here because I don't think we need it anymore. Now this code is relatively messy, yeah. So don't think too much of it. It's just to give you an idea, yeah. So for what we now want to do is that we kind of want to create a plane that has the shadows, and for that we say rn create cube. No, actually, I could create a cube, but it wouldn't work so well because you wouldn't actually really see the light effects and the shadows. I mean, you will see the shadows, but not so much the light, which is not really gonna help our cause, yeah. That what we're trying to demonstrate here. So instead, we're going to load a model, rn load model, yeah, and this model is we're gonna call it plane, and the model is models. No, yeah, models. Jesus. Uh, I just have to check really quick that I have it here. Yeah. Yeah. It's called Scalar Cube. It's one of the leftovers of earlier builds where I used it for models to be inside a relatively large room, and I could scale them to real world sizes, and I just didn't change the name, so it's called Scalar Cube. And we want to sort of scale that model to a certain size. I think I have it here. I just have to check really quick. Da 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 da. Hang on, where is yeah. I will have to come up with a number really quick because that model is relatively huge. So Rn scale model 3V. I think it was. I'm not sure now. Let's say 0.5, 0.05, and 0.5. Let's just leave it at the center position, and the truck will sort of be eaten by the plane. Yeah. Yeah. So I will. Yeah, that's plane. So you will have to define the name and obviously the vector. So let's see. See, there's the plane, and the car is sort of stuck inside, which is kind of interesting. So you know the wheels are that's probably a very cheap way to simulate snow. But yeah. So let's just make the plane a bit bigger here. Say 0. No, actually, let's just say 1.5 because that's funky. So 1.5, and let's make it a bit thinner. 0.2. Like, this is an actual cube, so there's a lot of vertices and a lot of shit going on. And see, now we have a really large and nice plane that we can do stuff with, and we want to add a texture for this plane. Yeah, so we're gonna say rn add texture, and the texture is called we're gonna call it it's under textures, and it's called I think scalar cube. No, that's my Fraps recordings. It's here under it's called large cube. Yes, that was, yeah, large cube. I didn't I yeah, I can't remember the name sometimes. So and we want to call it plain text, not text, text. And we want to assign that texture to the plane, yeah. So rn set model model texture. The name is plane, and the texture is called plain text. Yeah. So I think you will get the idea of what's gonna happen now. Pretty much that. So you this is you know it's not entirely accurate, but yeah, we we could kind of go and I could show you another command. It's called rn position model. Yeah. And we want to move the truck. We don't want to move it on the x-axis, but we want to move it on the y-axis, say 2 and 0. So it, yeah, not f6, f5. I'm not sure what's gonna happen, but you can see that's sort of like on the ground. Let's move it up to the so that it's sort of that the wheels touch the ground as it should be. Maybe 3.5. And another thing is that we want to position the camera a bit up, say 10, because we don't want to, be in the ground all the time. So there we go. We're a bit, yeah. So we want to move the camera maybe a bit further back, say 100, and we want to move the camera up to 20, maybe. Yeah, so that's good. So we are now at like a good position that we can see the truck with, as such. Yeah, so that's that. Yeah, I also want to. I hope I can do that really quick, because there's another cool command that I implemented that will help you for many reasons. For example, if you want to look at points from a different vantage point. And that command is, well, first of all, like I said before, you can have up to 16 cameras. So we want to create a new camera, and that's called rn new camera. And we want to call the camera cam2. And you can already define at which location you want to put this camera at. Yeah. So let's just say 0.0, 20, and 100 positive. Yeah. So as you can see, we position our camera away from the truck, and this would be in front of the truck. Yeah. And we don't want to rotate the camera, so we just leave the default values, which is 0. rn new camera, and that's it. You create a new camera, pretty much, and let's create a new global variable, global current cam, right? And to switch cameras, let's just assign the key C, because that's camera. I just if if key down, key C, if current cam is 0, then current cam is 1. And now the command to do this is rn switch to cam. Oops. Switch to cam and the name. You just have to say to which camera you want to switch to, and that's cam2. Yeah. That's it. And like else if current cam is 1, then current cam, yeah, we're gonna correct the errors now. Current cam is 0, and rn switch to cam The first one is always called default, and this is case sensitive. Yeah, this is really important to understand. Like if you write like default with a small d, it will not work. Yeah, so this is case sensitive default, and end if and flush keys, because we don't want to react to any further input. Yeah, so if you do this now, we're now here, and we're now with a different camera. If I press C, yeah, boom, boom, and I can sort of it's not entirely implemented yet, but yeah. So you will yeah, I will have to make it so that it's yeah. But we want to. It's, you see, it's not entirely perfect. This is just the base to the engine. Yeah. New camera, and we want to say RT, a rotate camera. Cam 2. Oops, cam 2. And we want to rotate it horizontally, so that would be 180, I think. So, oh no, Jesus, I'm still used to the old commands, so that would be RN. Yeah, see, it's not, yeah, the camera system is not entirely working yet, but I can spin this camera now. I don't know where I landed, but I landed somewhere in front of the car. Yeah. Yeah, but you get the idea, I hope. Let's just see if we can. I don't think that's correct, but yeah. So we're somewhere else now, and I think I'm sort of. Yeah. So that car is somewhere else, and I don't know where. Probably on the other side. Yeah. So yeah. We just spin 180 down. So these are OpenGL vectors. Yeah. So this is 0, and this is probably the way we want it. Back. No. So this is relatively interesting because it. Yeah. So. Oh. Yeah, you can see that the camera system is not entirely perfect yet, but I'm working on it, and hopefully this is, let's just, if I spin back and do this, or, if I spin back to this sort of edge, yeah, so you can see that we're basically on the right side. I just have to position the camera correctly. Yeah, so that's not working correctly. I just gonna experiment here a little bit. So there we go. See, you can now switch the cameras. It's boom, 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 boom. Okay, boom, 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 boom. Okay. So I mean, it's I really have to figure this out. In the correct way. It's not the way it's supposed to work, but you get the idea that you can have up a lot of cameras, and you could also position that camera at a different sort of point, and rotate it. Yeah, but just so that you know that the engine is capable of doing it. But now we really want to cut to the beef. Yeah, oops, I didn't want to show you that. I just wanted to know why my phone was blinking, and I have 3 Facebook messages here. Yeah, we really want to cut to the beef now, and that's the lighting system. Yeah. Technically speaking, the engine is capable of handling an unlimited number of lights. Okay. But well, I mean, we can render shadows, that's not a problem, but we are limited to the eternal number of 8 on most hardware. Yeah. Some graphic cards support up to 16 hardware lights, but you should always assume 8, for the simple reason that these are extremely expensive computational wise, and You shouldn't really be using those too much, and this is why there's a limit of 8. Right now I'm going to show you 1. Okay. Now it's also important to understand that your geometry should be relatively high in polygons if you want to see the light correctly. Yeah. It's yeah. So let's just create a light here. Okay. Rn create light. Yeah. And we're gonna call this light light. It's also important to understand, like, okay, let me start over. I did a little bit of research on lighting in games, yeah, and it so turns out that in almost all scenarios there are three types of light that are most commonly used. Yeah, the first type of light is a sort of omnipotent light, which is called ambient light. Yeah, the ambient light is like it comes from everywhere and nowhere. Yeah, and it's like it's everywhere. Yeah, that is called ambient light. The second one is called a directional light, where sort of the light comes like it's sort of like the sunlight that it's yeah, it sort of has a direction, but the source is so far away that it would almost kind of seem that it's infinitely far away, and the direction the light goes is always the same. It doesn't change. Yeah, that's a directional light. I don't have that yet, but I'll put that in. And the third one could be split into 2, but I decided to go with the spotlight because it seems to be the best way of doing it. Yeah, spotlights have a finite angle and range. Yeah, I didn't implement the range yet, but I implemented the angles. And yeah, so that's a little that's how lighting in the engine works. So okay, let's go. First we want an ambient light, and we want this light to be Rn set ambient light, and we want it to be really dark, say 40 40 40. Yeah, and we're gonna take this away real quick, and now we have lighting here, and this should be sort of make it, yeah, so it will not have an effect unless you have actual lights in the scene, because this doesn't do anything. It just, you know, there is no use in having ambient light without other lighting, really. Yeah, so therefore what you will have to do is Rn create light, and we're going to call this light. Okay, and we want to position the light at a certain point in space. Position. Hang on. Yeah, hang on. I may have forgotten to put that in. Rn. Oh no, set light position. That's it. Yeah, Jesus. And the light is called. That's yeah. There are so many commands I can't remember myself. Oh Jesus Christ! I really have to write them down. Okay, Rn set light position, and we want this light to be at 0. We want this to be at, say, 200 in the sky, and I think 200. I really have to I have to check the other code real quick. Bum 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 RT RN actually. The light is somewhere in the beginning of the, yeah, so yeah, it's a positive, so 200. Set light position, and we want, like, you can define at what point the light is looking at. right now. Yeah, if you don't set that, it will look at the center point of the scene. Yeah, so like it will look at the center coordinates of your world unless you specifically decide that it's like looking at something, or something else, as it were. Yeah, uh, and it's also always a good idea to sort of put the light at the very beginning of your code, because that makes sense. Um, Now, for the models, you can also define their shininess, specular properties, um, and we're gonna set a few things for the truck, just to show you that it's hello, that's possible. Rn set model ambient and diffuse, and it's just one command that sets both, because in most cases you just need those to be in one, and I like it to be at like half strength. Um, just that's a good value. Rn set model specular, and we want this truck to be say let's say 200. That's a good value to just to demonstrate. And Rn set model shininess. The Now with the shininess, it's like the lower you go, the higher the shininess is apparently. So let's just say 25. Um, so that's that, and I hope that this works. Um, you know how it is that in the live demo it never runs the way it's supposed to. Uh, There's a parameter missing, the alpha value. Yeah, I have to define a default for that, so specular is 255, so let's go. See, and now we have a little light going on here, see, that shines from a certain position that is somewhere out there. Yeah, so that's that, and I'm going to show you the shadows now in a second. Yeah, I have to do something real quick. I'll be right back. Yeah, so I did have to go to the bathroom there. I do apologize for that. And yeah, so you obviously want to set some values for the light as well. Yeah, so Rn set uh, light color. Yeah, which also incidentally sets the ambient and diffuse settings for you. Yeah, so we're gonna set this at half strength, and we're gonna say Rn set light set light specular, and that's light. uh, yeah, this new keyboard is strange. Set light, and we want to put it at like almost full strength. Yeah, we don't have to define the third value. And now another thing, in order to cast shadows automatically, you will have to define what what model you want to appear the shadows on, and there is a certain special command to do this. Yeah, and that's a very important command, and that is called rn set model is main terrain. Yes, so I just have to check here, set model is main terrain, yeah, and that is called plane, and you have to set this to true. Okay, so with that, this particular mesh then gets a certain flag that is respected during the rendering phase. Okay, now I do hope that this is working, because like in live demos you never know what's gonna happen next. But you can see that we have a nice shadow now of the car. Okay, and the default value for shadows is I think 512. Yeah, I set it to 512. Okay, and you can also see that the model is now relatively shiny. See, if I move the camera, you can kind of see that the shininess, see, of the car is more realistic, and there's a nice shadow being cast automatically. Um, Another thing I want to show you is that this function is not entirely complete, but it's a start. We are not entirely finished here because there's one more thing I want to show you, um, and that's RN enable light debugging. Yeah. Uh, what this does is relatively simple, and uh, you will, oh yeah, you will have to also say that you want to, and actually, and yeah, uh, yeah, this is true. Yeah. And now what happens is that a line is drawn from the point of where the light is located. Maybe I should see the light is right there, here, and it's shining down. So you can kind of see what's happening in your code. I will have to make this a bit different so that you sort of see kind of the cone where it's like shining here and shining down there, you know, like. But you get the idea in the moment. Um, yeah, so that's the light debug sort of mode. I'm going to actually, where was it? Uh, I'm looking for the camera speed. Here. 2, so we can move a bit faster. Yeah, so that's a bit quicker. You can see. Um, yeah, so that's that. You can also see that if we're looking below the car here, that this is exactly the point where the light is shining at right now. Uh, there's no anti-aliasing right now built in, but I'm going to do this uh, at some later point because this, like, doing the shadows was already, like, that took a while. Okay. And in order to speed things up, I'm just going to copy code from here. Um, just, you know, so that you can see that the light is movable, so or that it will react differently to the different obviously I have to change this because this is you know, not final, but if I do this, um, I will now be able to move the light, see, and if I move the light in another direction, you can see that the shadow is adjusting to that. I can also move the light down or up. No, oops. I will have to see which one is down and up. See it. See. Okay, so this is going down here, and we can move the light, say, to a different position. Say here, and you can see that the spotlight uh, is behaving correctly. And I can also show this to you with more arbitrary geometry. And another thing is that you can change the shadow map quality on the fly. And for that, I'm just going to copy and paste another code here for plus and minus. And there's a command for this as well. And the command to change the shadow map quality is called rn set shadow quality 2. Yeah. But it's also important to understand that the shadow quality can only be, or how do I say this, is directly related to the height of the display. Yeah. So like if you were to display this at full power in 1920 by 1080, which is this, you could set the shadow map quality to 1024, but this is set to 900. So the maximum would be 768. Yeah. So just to show you the different effects, you can see the shadow is relatively jaggy right now. If I press plus, oops, it will, yeah. So as you yeah, oh yeah, I will have to copy a variable. Sorry about this. We're just gonna put this here under the locals, uh, and this should work now. I'm sorry. Yeah. So if I press this, you should see the quality improved. If I do this minus, you see the quality is getting worse, but it makes it faster. So this is 768 now, and if I sort of move the shadow down and move it to the side, uh, the quality is still relatively good as such. We can also turn around the light and just move it to the other side. You can see that the light is moving and the shadow is being cast on the other side. Um, yeah, so but just to show you that this also works with different geometry. So I'm just gonna say relay, and I'm going to load the relay JPEG texture so that you can see that. But I will have to scale the model because the relay is unbelievably huge. So Rn scale model. I'm just gonna. I don't rename it now, but it's going to be the Orion relay truck 0.2, and so just to see, that's the relay now. Maybe we can make it a bit bigger. Maybe 0.4, so that you see, and it works with increased shadow quality. It works with arbitrary geometry, and we can sort of make the light come closer, and you can see that the shadow is adjusting accordingly. See, it works with this kind of geometry too, and if I come close, it doesn't really work so well on this model for right now. See, now you can see that there. It's relatively shiny, so you can set the shininess to whatever you want. But I want to go back to no. What I want to do next is show you two more things. Okay, we're almost done with this very long session of a DevBlog. I don't think that's I've ever done something that long. Now, we loaded just a flat model here. Yeah. Now we can change this to something that I experimented around on, and it's called what it's called, terrain 2. So I have to check real quick if we have terrain 2. No, I'm gonna have to copy that over real quick, and I'm going to keep talking because that's quite a good example to show this with. So models terrain 2, and we're gonna go into the demo folder, models, here, paste terrain 2, and textures. Do we have it? No, I also gonna have to copy the terrain. Sorry about this. I should have prepared that, but yeah. Anyways, terrain. So we're gonna go here, reason demo, and textures. Now, it's a little arbitrary hilly terrain that it's not really impressive, but it should give you the idea. So we're gonna say terrain 2. Oops. Yeah. Terrain 2 dot object, and it's called terrain.jpg. Yeah. So we can leave the rest, but I think we have to scale the model just a tiny bit down, and we're gonna have to maybe we have to scale this just, and we're gonna have to say there are some hills, so I want to show them to you. I'm gonna say 0.5. Oh, yeah. So that didn't quite work. I do apologize for this. Oh, yeah. Maybe a slash. That should help for folders. So now you can already see that the shadow is also cast on arbitrary geometry. So if I scale the model to say 0.5, 0.15, which is half of what we just had. So there we go. You can see that increase shadow quality, that the shadow is also cast on a sort of, you can see hills as such, that the shadow bends around the hills. Now obviously the relay is not gonna stand in this kind of environment. It's also sort of floating, and we should sort of maybe, but well, anyway, you get the idea. It doesn't have to be exact right now. Yeah. Now the last thing I want to show you is that also we're not just doing 3D here. We can also do 2D, and I am going to, yeah, I'll have to copy something real quick, and we're gonna copy over the logo of Genesis, the first expansion. We're just gonna put this in this folder here, and you can also display images in certain orders, or in any order you like, really. Now the way it works is relatively simple. We can handle an unlimited amount of images in 2D space. Yeah. So if we want to put in an image, we say rn load image. I think, yes, load image, and the name we're gonna call it logo. Okay. Logo, and we're gonna call we want to load the OG logo.png. Yeah. Now that's it. That's all you have to do. And if you want to see that, yeah, there's a call which is called Orion render 2D. Okay. It's important that you call 2D after the normal render, because if you call it before, it will just disappear and wouldn't make sense anyways. So but if, like, this will appear in the top left corner. Like I flipped the coordinates of the OpenGL system so that like that it's like understandable for mere mortals. So it starts in the top left corner, and what happens hopefully is that you will see the logo, and there it is. See on the top there. We are respecting alpha transparency. So see, there it is. It's like as the way it should be. And if that's too big for you, you can also say rn resize image logo, and we want it to be, I think this is 320 by 75. Was it 300 by 75? I'm not sure. The logo is 600 anyways, but if you do this, it will sort of make it smaller. See in the top left corner there. What you can do, obviously, there are two more things I want to show you, and then we're done. Rn set image position. Yeah, so if you want to we want to say logo, and we want to have it at say 100 and 200 maybe. Yeah, so that should do that, so it's now there. And I'm just gonna remove this because we want to see it large. So just in case you haven't seen this, it's now located here. Okay. Sorry. And the last thing I want to show you is that obviously we support alpha transparency. So set image alpha, and that would be logo. Image name is logo, and we want, like, the values you can supply are between 0 and 255. Yeah. So if we want to see it halfway through transparency, you just say 128. Okay, and that's it. See, it's now sort of shining through. Sort of transparent. See it? Yeah. We can do that too. So yeah, that's it. In the moment, that's all I have to talk about. Yeah. Um, I'm going to disappear now for like 2 weeks or something to refine some of the small bugs you have seen. Um, but I do hope that you like what you've just seen here. And please leave a comment, please leave criticism or suggestions as to how to improve things. And that is it for the moment. I'm going to work on this, and I'll see you around. Sayonara.